This is a rendering of a coverage pattern for a rover driving on the moon near a skylight. We call it a lawnmower pattern. So the rover's driving back and forth from south to north, and then turns, and then comes north to south, and then turns and continues that pattern until it hits the hole, where it has to travel in circles, curves around the hole, comes back, and it continues that pattern until it's completely covered the scene. So the goal is to get imagery and geometry for the entire area around the hole. LRO has taken some really incredible images from different angles, showing that you can look deep into the pit. So we've hand modeled the skylight itself. It's based on the Marius Hills pit. What a skylight is an opening in the surface of the moon or on Earth to a larger cavern underneath. In this case, the cavern is a lava tube, and lava tubes may be good places for people to live, for people to operate from when we first go to the moon, to Mars. On some planets, they may hold life. They preserve geology, so the caverns underneath the surface are undisturbed. They don't get hit by meteorites. And so they're very interesting scientifically as well as for exploration purposes. So the purposes of this simulation is to let us test visual odometry, obstacle detection, hazard avoidance, and different exploration techniques so that we can develop software without actually going to the moon. So we're generating left and right images here, and the goal is to run both of those images through both stereo processing so that we can detect rocks and detect craters and detect the shape of the ground, and also to track features over time. So you might track little rocks and watch how they move, and then that will tell us how the rover's moving. We've taken elevation data from around the Apollo 11 landing site, where there's very, very high resolution data, and added small craters and rocks to that data so that we get this very, very high detail. The boulders are generated using a distribution that represents what you would actually see on the moon. So the model is calibrated with data from the Surveyor missions, which were early NASA missions to the moon, to actually count the number of rocks, count the number of craters, and the size distributions and things like that. So this is a scientifically accurate representation of what we will see. So we've generated this data in stereo with left and right images, and you can watch that. You can watch the whole traverse in 3D if you have 3D glasses.